So today we will start with topics for creating a physical layer in repository. Then we will see how to create business model and mapping layer. Then how presentation layer is being changed to pull all the objects that are required for analysis. And starting with physical layer of the repository, we will see how to create entirely a new repository from the beginning. So we have our client as ABC, who supplies food to restaurant chains, okay, different types of products to restaurants. So we will see how RPD can be built for this customer by importing the sources from their schema. Okay, so we'll start with our administration tool, creating an entirely new repository. Then slowly we will import all the objects that are required. Then we will see how to bring in all the objects from your physical layer to BMM and then BMM to your presentation layer. Okay, so for this, for creating a new repository, what should we do? Go to your BI administration tool, which is here, or else go to all programs, Oracle Business Intelligence. There is something called BI administration. Click on this. Okay, so this will open administration tool window for us like this. So there is an option called new and offline and online and MDS XML. So the other three, other than first one, are used if there is an RPD which is already created, and if you want to use it, you use other three options. If you want to create entirely new repository, you can just click on this icon called new. This will open a new RPD window screen. Okay, this is very important step for us. So this is how you create your new RPD. Okay, so then you can give the name of the RPD as, I'll just give it as COXA. Okay, now you can see that by default your RPD location will be instances home, BI foundation, BI server, core application, repository. So this is the place your RPD is going to save, okay, by default. And you can give repository password as welcome1 and give the same password as welcome1 again. Okay, just click on next, and you have connection type as ODBC, or whether it is a Oracle call interface, or whether it is DB2, or is it SAP BW native, or is it as an Hyperion database or something like that. Since our database is also an Oracle database, since our product is also an Oracle product, and even the database is present on the same box, you need not to create any ODBC connection. You can just go for Oracle call interface 10G and 11G. Okay. Okay. So when you select it as Oracle call interface 10G or 11G, we should provide a data source name. My host details are, I have saved it for our practice. So this is my DSN, which gives the location how to connect to your database. Okay, so you can see the service name is ORCL. Generally you can just give ORCL, but it was not working for us for some reason, for some network reason. So we are giving the whole description of our data source, and username will be supplier 2, because I want to use all the tables which are present under this schema. So supplier 2, click on next. So when you click on next, it will ask you an option to import tables, keys and foreign keys. Keep it as it is, just click on next. So you can see that your ORCL data source contains many schemas. Your HR schema is also there. Your dev MDA schema is also there. Your dev BI platform. This is created when my RC is run. Okay, even this contains few set of tables. I told you, right, all SNQ job, all those system related tables which are required for OBIEE to run smooth, all those tables will be present. And your MDS also will contain all the MDS related tables. Now, your data warehouse here will be supplier 2 by default. You can click on this and you can start with our practice. Now,
Chanakya,
yeah, go ahead.
how we will know our data source, like the whole name, how we can identify that source name?
I mean, I'm not getting you.
That data source, right? How
Here,
we will know like what we have to write in there?
okay, for our practice as of now, you can use this only even in your servers also. Okay, but how you will come to know is there are multiple ways. First thing is you should know what is your database, where your client, where your server details are present. Then there is a place called app data BI product. There is something called network admin TNS names.ora. So this file called tnsnames.ora, TNS names ora file will have all the details about your database servers and where your data source like ORCL or ORCL connection data, where they are present. So for ORCL, you can just give ORCL in the DSN name, but this ORCL alone was not working for some reason. That is the reason I am copying the whole detail and I am pasting there. Okay. So when you install
But this will be created by default, or we have
this
to
will be
use
created by default when you install your database in your server.
Okay.
Okay. So when the database is installed in the servers, obviously this SQLnet, TNS names or a listener, all those things will be created by default. Okay. And this TNS names.ora is the file where it contains the information about your database servers and how to connect to them. Okay. Fine.
Okay.
Okay. As of now, just use the DSN that you have even in your boxes 172, 173 and all. We have something called this one, DSN file that I saved. Okay, you can use it for there itself. Okay.
The connection type is also keep on changing. No, Chanakya, because for one project we will use different connection type and
It's not
for different.
no connection type. The you meant to say like OC 10G 11G, right?
Yeah, ODBC,
Okay, that
OCI.
is with respect to your database and where your database is present. That is not with respect to our project. Okay.
Oh, okay.
Yeah. So if your if there are two servers, say server 1 and server 2, and if server 1 has all OBIEE related stuff, and if server 2 has all your DB stuff, then what you do, in first server you create ODBC connection to server 2, then you define in the RPD all the ODBC details. Okay. Fine. If it is in the same box and if it is Oracle database alone, then you can give Oracle call interface. So by default, it communicates to your database. Okay, that's fine. There are a lot of ways of doing this, but as of now, just keep that in mind. Okay. Now, so we will import few tables into our schema here. So we will try to import D1 calendar, D1 customer, D1 orders, D1 products. Okay. So what we will do here, we will select D1 calendar, D1 customers to, D1 orders to, and there is something called D1 products. So all the tables have been pulled to your RPD. So by default this creates a connection pool. We can name the connection pool as supplier CP. So you can give any name, that's up to you. And your call interface will be default Oracle call interface, and your DSN is the fully defined DSN which will point to your host. Okay, so this you can see the data BI 01-PC. This is the host. The same 171 box is the host. But since if I give ORC it's not working, I am giving the full description. Username and password is supplier to that I have provided. And connection pooling for 5 minutes and parameters supported and everything, you can just leave it default. Click OK.
Chanakya, I have a question.
Okay.
Like now we added like 4 tables, right? 1, 2, 3, 4.
Yes, yes.
Later on, like we have to one more table comes into picture which we have dropped out. After we create all this RPD and all this stuff, is it possible at a later stage to add one more table, or like
Yes.
we have to create a new RPD?
Not required. In the same RPD, any number of times you can pull in any number of tables.
Okay, cool. Thanks.
Okay. Yeah. We will see. We will not just finish with these 4 tables. We have around 25 to 30 tables coming in. Slowly, in each exercise, each table will be coming in, and we will see how to model our physical layer and BMM layer slowly. Okay.
Okay. Okay.
We have around 18 to 19 exercises. So we will see how to model everything. I will tell you all the concepts. Need not to worry. Okay.
Okay. Thank you.
Yeah.
And Chanakya, I have one note. The calendar, customer, and orders products is there. No, they are dimension tables. These all dimensions are present in the fact table. Yes.
This is orders is a fact table. This will have measures. Okay. See, this is a sample schema. This is a sample schema. Okay. See, for practice, I cannot get you real time schema and work on that, right? Because it's very difficult to model dimension data and fact data and all the joins, everything. So this is what we created for ourselves, and even we took few things from this one. Previously, Oracle supplied. The Oracle will supply this default schema for practice. Okay. And I have manually created some tables in this, and so we made it stable. So we can use this for all the practice. And we have this PDF, right? So you can go through it and start practicing. Okay? Yeah.
Oh, okay.
Okay, so just click on. Okay, go ahead.
You have selected 4 things, right? For control, by using control. Should you pass them to the other side of the table, or you will just select them like that?
No. You have 2 options.
You have a arrow keys in your screen, right?
Yeah. Okay.
You have to import them from that screen to this screen, right?
Okay. Now, 1 minute. So now let me see. Even Sunil asked me a question. Suppose now we are creating like this. How will you import one more data in future? Let me delete this from D1 calendar to. Let me import only D1 calendar to. Now you need not to do the same RPD process again. Your RPD, coxa.rpd is already there. On supply CP connection pool, just right click and do something called import metadata. Okay. Just click on this. By default, you will go to tables, keys, foreign keys. Now you will not be asked whether it is a default Oracle call interface or whether it is something else. Okay. So only thing asked is tables, keys, foreign keys. Click on next. So immediately you will be taken to supplier CP connection pool screen. So from here, just there are 2 options called import selected and import all. Don't go for import all. Just go for import selected. Click on this, click on import selected, click on finish. you can see your D1 calendar 2 table has come back, right?
Okay. Yeah.
And you can rename this, because since it displays, generally it should display your DSN name, but my DSN name is fully qualified name. I don't want to display such a big name, so you can just give it as ORCL data source, right? And your connection pool is supplier CP, your supplier 2 is a schema. You have all the different type of tables. There are 4 tables which are being pulled in. Okay. So now we will see how to create aliases for them, how to make a physical join between them, how to define the joins, so that when Oracle BI server gets a request from your application or your presentation server, how Oracle BI server sends back the query or the results from your database to your application. So we will see all those slowly. Now this step we are only importing all the tables, like 4 tables. Okay. Next. So you can see the connection pool properties that already I told you yesterday itself. Like data source name is the configured access to the database to which you want to connect. Username and password are also configured automatically during the import. Enable connection pooling allows a single database connection. That for 5 minutes I gave right here. So enable connection pooling for 5 minutes. This one, this property. Okay, so what does this do? This remains open for a specified number of minutes for use by future query requests. Connection pooling saves the overhead of opening and closing a new connection for every query. So if a particular query is being run continuously or a new query is coming in, so your server should be able to open connection to database on continuous or in parallel. So to avoid that overhead or extra burden to your server, what you are doing, you are just, if a connection is opened, if a gate is open, you are keeping it open for 5 more minutes. Otherwise there should be a security, he should keep opening gate for you guys whenever someone passes by. If there is some timing, like every 5 minutes I will be open. If no one is coming within 5 minutes, I will close it. Again, if someone else is coming, it will open, and for 5 more minutes it will remain the same. So all the queries which comes, it can go ahead. So the extra burden or the extra time is saved. Okay, like that. So all the system properties and all, don't worry much. So it is all internal, right? So you don't care much about that. Okay. Examine the properties of your database object in physical layer. So you already saw the different type of features that are supported and everything. Okay. Next. You can see the properties of your physical table in the physical layer. Okay. So how do you do that? So for this connection pool, just click OK. So right click on this, check the properties of your table. So you can see the table type as physical table. You can have 3 different types. One is stored procedure and one more is select. So stored procedure and select will come. If you want to select, how will it act? If you want to create a view, like select, your view is nothing but a select query, right? So if you want to create a view in your physical layer, you can go for select. And if you have any stored procedure using your PL SQL, you can even bring in the stored procedure to show the results. And there is something called this table as cacheable, and you have something called columns. What are all the columns this table contains? And you have something called keys. You have foreign keys, properties. As of now, keys and foreign keys are not defined for this table because there is no defined join between these tables as of now. So you are going to define all the joins using your data model. Okay. So as of now, click on cancel. Just we'll go to the other practice. Now, update row counts and view data. So why do you do this update row counts and view data? Yesterday I was telling you, when you create a RPD, just to make sure that whatever you did, whatever connections you did or defined are proper. In that case, you can just right click on this table, update row count. So when you put your cursor on the table, it tells 474 rows. That means whatever you have written there is proper. Now go here. So your supplier 2 schema has a table called D1 calendar 2 and has 474 rows. Just to confirm that what you can do in supplier 2, this is supplier 2 schema, right? So how do you get number of rows? You have something called count star. So select count star from D1 calendar 2. So when you run this, you should get value like 474. So this is what is getting displayed in your RPD. Okay. And if you right click on this and click view data, you get all the data which is present here in your table. This means that your connections are proper. Okay. Next. And you can save the repository. Just how to save the repository? There is a save button here on the toolbar directly, or else you can go to file and save button, or else you can just do Control yes. It will ask for, do you want to check global consistency? At this step, at this point of time, I will not explain you what is consistency. In the 6th exercise it will come. What is consistency? What are the rules to check consistency and all. Even if I check now, it won't fail because there is nothing in business model and mapping. It will fail because there is nothing in business model and mapping layer and presentation layer. Okay, don't do this now. Just click on no. So your RPD is saved in that folder. You can go here. So where is that folder? Middleware, your instances 1, and where is it? BI Foundation, core application, repository. You can see that your coxa.rpd is being created. Okay, on 3/21/2015, March 21st. Alright, so your RPD is being created and you are good to start with further development. Okay, good. Now we will see creating alias tables for our table. So why do you go for alias tables? What is the reason that as a developer you go for an alias table? Okay, we were discussing before that OBIEE supports star schemas, as well as if the same table is being referred by multiple fact tables, in those cases, or multiple you can say data marts, in those cases there is a chance that it creates a circular joins, and your OBIEE does not support any circular join. Okay, so what is a circular join? Here you can go. Suppose say this is a fact table, dimension table 1, dimension table 2, and you can remove this join. Or else you can do one more thing also, like you can go for one more dimension, you can go for one more fact here. So suppose if it is like this, so this will refer dimensions, and this will refer this will refer this, and this will refer this. So your DIM3, DIM1 and DIM2, see how they are. This is called a circular join, like this, like this, and like this. In the same direction your join criteria is there. DIM3 refers DIM1, DIM1 refers DIM2, DIM2 refers DIM3. So like this. And your DIM3 may not be not only used here, it may be used with one more fact table like this. And your DIM2, instead of like this, you can have one more table separately for DIM2. So to avoid this type of joins, what you do here, you need not to have this type of join here. So how will you avoid this? You can DIM2 will refer this and your fact will refer this. So you avoided circular join here, you will remove this. So you won't use this join anymore. So this is fine. So what you did, when there is a join between DIM2 and DIM3 and it is forming a circular join, you are creating one more table for DIM2 as alias DIM2. The same table, what does an alias do? Alias will just give you a different name. That's it. Like the same myself or Chanakya or anyone yourself, Sunil or someone is being referred with the nicknames. Like Chanakya, suppose say Chanakya Pratap or something like that. So you are just giving an alias for your same table. It is nothing a different table. As you saw in SQL query, you give aliases for tables when the same table is being referred multiple times. So the same concept you do in OBIEE also. To avoid circular joins, what you do? So this is not a circular join. See, in same direction you cannot make any logic. See, this goes like this goes like this, but this is again not coming like this. So the arrow is marked, arrow mark is pointing from your fact to dimension. So this is not a circular join. Okay, so you cannot make either in clockwise or anti-clockwise. All the arrows are not pointing in one direction. So what does your circular join do? Your circular joins takes your query to infinite loops, right? So your same thing. If you want something from A, or you can call it as deadlock, right? So your OBIEE does not support your circular join. So that is the reason. First thing you go for your alias tables. And one more thing is, if the same table is being referred by multiple fact tables, and at each fact table level, your dimension definition may be different. The keys with what it is joined or the data with what fact table is present, it may be different. So even for that reason. And to have your star schema separated each with each other, so you will have your dimension aliases created for that. Okay. So we will see how to create aliases and how to proceed further. Now for D1 calendar 2, so what is one more advantage is, you need not to touch any base table. When you create your alias table, you are not creating any object in the database. It is only created in RPD and you are still pointing to your base table D1 calendar 2. Okay. So let me give an alias name for this by creating new object alias. So you can name it as DIM D1 calendar 2. So what I did, I gave right click on my base table and create new alias. Okay, new object alias. Click OK. So Your D1 calendar 2 and DIM D1 calendar 2 both are same. When you check properties for this table, you can see that your source table is D1 calendar 2. And for your base table, you can see you have different types of table types like table type, stored procedure, select, but you cannot make any changes to your alias table. Everything is read only. Okay, because everything, whatever changes you make to your D1 calendar 2, all the changes will get inherited by your alias table. We will see that. Now, suppose let us create a column called alias column as a physical column in your table with type as varchar and length as 15. Click OK. So you can see that your column is being created in your D1 calendar 2. Now observe your alias table. So your alias column is created. Did I create any column in my alias table? No. So whatever change you make to your alias to your base table, corresponding alias table will get affected. And imagine the flexibility if the same table is referred by 10 different places in 10 different positions. Suppose you have 10 alias tables for this. Okay. Now all the alias tables will get affected with your new changes. Suppose say now D1 calendar 2 I have new object as one more alias. You can give it as DIM underscore D1 calendar 2 test. Click OK. So you have alias column here. Now from your D1 calendar 2 remove this alias column, delete it, we will see. And now observe both your DIM D1 calendar 2 which is dimension table. So your alias column is been removed and your DIM calendar 2 test, your alias column is been removed. Okay. So any number of aliases it will get affected. Okay. So as of now I don't want this, so you can delete it. Okay. Fine. Next.
There are chances that we have to create more than one alias.
Yes.
In practical situation.
Yes. You create mostly for day dimension or time dimension. What you say, you will have for ship date, it will have different. For order date, it will have a different dimension table. Suppose say if you are joining it with a sales table, and you have to join with suppose say previous to the previous year data to get current year data and different type of date criteria. When you do that, you have your day dimension is being used in as different type of aliases. Okay. And most of the times you don't want to touch any. Pardon?
We can make alias even for the fact table the same way.
Yes, you can make, but what is the use? You can make for anything. See, if it is, see, it is alias. Alias is a concept for a table. You don't care whether it is a fact or dimension. Right? Even your fact table is a table. That's it. See, you know that it is a fact table for you. Right? But in physical layer, everything is just a table for me. Okay? For tool, it is just a table. You don't care whether it is a fact or dimension. So whatever it is applicable to your dimension table, the same changes are applicable to your fact table also, because it is a simple database object. Right?
Yeah.
Okay.
And for facts also we have to sometimes create multiple alias.
There may be scenarios like that also. Yes.
Okay.
Yes. But very rare. I have seen it very rare. But still, you will create it. Okay. So at this point, please don't dig in much. You will get confused. Okay. So just keep in mind, be very simple. Just keep eliminate any other complexities. Just we'll start from the basics. Slowly we'll increase the complexity. Even then, see, It's like learn the basics, and if you practice twice and thrice also, you will not properly understand. Do it 5 to 6 times. Almost it takes 15 days for you guys. Suppose if you are sitting 4 hours in a day, I think 15 days is maximum enough. So once you do it, again second time you do it. On the job when you start also, you will not use all the concepts. Very minor concepts you will use. Okay, again you will forget something. Again start practicing like that. It is like that. Okay, so you need not to worry much on this. So just keep in mind how to create an alias, why aliases are used, okay, and that concept. And any table can have alias, whether it is a fact or dimension, anything will have it. Okay, fine. Now modify the data types for one of the column, because we will use this YYMMDD column to join it with our fact table, and our fact table data type is int for this column. So I am just changing it. And similarly your dimension also will get affected, so you need not to worry. And create the same alias tables for your DIM customer, product and orders. So for DIM customer, new object alias, name it as DIM D1 customer 2, and for product you can name it as DIM D1 products. And for your orders, you can name it as fact D1 orders S2. Now we have 4 tables and their corresponding aliases. So see, now you need not to make any changes to your tables. Base tables will remain the same. So if you want to make the change, all the alias tables will get affected. So it's a one-time change for any of the table. If I have 10 alias tables in all the 10 alias tables needs to be changed, just go make one change to your base table. All the 10 will get affected. You need not to worry much, right? Now we can save this. Don't check consistency, and this RPD is saved. So in the practice, in the PDF it says ABC RPD, ABC RPD always, but I have one more RPD like that. That is the reason I saved it as Coxa, and you can give your RPD name however you want, however you wish, and you can start practicing. Okay, fine. Now next thing, how do you define keys and joins between your tables in the repository? So before this, what you can do, you can just look at data in the tables, D1 calendar to view data. So here you have I told something called YYMMDD, right? So here you have 1998 0711 0712. So this is at day level, which is unique for this table and which is not repeated. Okay, so this will act as a primary key. Your orders table also you can see it. So calendar, you can see view data. It will have 3 lakh records, and you have some keys called period key, prod key, and some cost extent. Okay, so here you can see 1998 0107. This is at most detail level. So this key and your YYMMDD in your calendar like acts as a primary key, foreign key. And since this is a fact table, you can make a join with your physical table, physical dimension table primary key. Okay, so we'll see how to do that next. Now what you can do for defining a physical join, you can select D1 calendar 2 on this. So hold your control button, select fact, select D1 calendar 2, right click on any of the tables. There is something called physical diagram. Just as of now, just select the objects, and there is a button called new join here. So in physical layer, if you make a join, it is called physical join. Okay, so first click your cursor on this table, and when you click, this will open an arrow button. So just click on D1 calendar 2 again. this will open a window with DIM calendar 2 as your So this will open a window with your D1 calendar 2 as your dimension table. So YYMMDD with period key. So this is how the join is defined between these two tables. Now just select one of the tables, right click on them, physical diagram, objects and direct join. So you can see that your address S2 is being joined with D1 calendar 2 in physical layer. Okay, this is how now how your database join will be driven. Similar way, define the join between your customer, your address customer key and customer new key. You can select the three tables. So you can arrange however you want. Click on the join button. So click on your orders and your products. There is something called product key in products. Here you have something called product key, and from D1 orders to D1 customer what you have? In D1 customer you have something called new key, and here you have something called customer key. Just click OK. Now you can see that how your star is.
Chanakya, how do we know that to which column do we should we map for a join?
One thing is you can look at data, but that is a tough job. Okay. The second thing is I was telling you in the data warehousing concepts about data model, right? So what is the data model? Data model is nothing but the definition of all your database objects along with keys and foreign keys and the join relationship between each and every database object, right?
Yeah.
So using your data model, so it is already given in your document here. The same way your data warehousing team will give you the join specification for each and every table that they create. Otherwise what you can do, you can just go to your table definition here. Suppose say you want to look at your D1 orders too, right? Now D1 more D. So go to your tables here, double click on your D1 orders too. We will see how the SQL has been defined for this table. Okay, then I will show you how to identify the joins. Okay, here constraints are not being defined.
You can use the foreign key concept.
You cannot use the, pardon?
Foreign key or primary key.
See, for this table you don't have any constraints defined, otherwise we will define it as primary key, foreign key, right? So from there also, from the SQL code also you can identify directly. So this column will refer to the primary key column in the other table. So like that. But here while creating we didn't define any constraint for this table. So that is the reason it is not allowing you, okay, to look at. But that's not actually required as of now. Just see, there are multiple ways. One way is data warehousing team will give it. Second way is go and check your SQL, your DDL script for your table. So the DDL script will have constraints like foreign key, references, one more key in the table, primary key table, right? So from there also you will come to know what is the foreign key and what is corresponding primary key for that. And you can look at data also. So if you find something unique in primary key column and the same information is being used in your foreign key. So mostly your dimension and fact will have one key column, that is for sure. Okay, your dimension will have one primary key column, that is for sure. And your corresponding fact table, it will have a foreign key. Okay, so you just need to identify what is the column name. That's it. Generally, it will be provided for you guys when you develop. You need not to run behind people to get that. It will be straightforward. Okay, it will while sending your data model itself, they will send it. Okay, fine.
Just in case we are looking at already Chanakya, if we are looking at already existing connections and we want to find out the keys with what keys they are connected to, how do we do that?
Yeah. So here, now I already made a join. This RPD is already present, right?
Mm-hmm.
So here you can click on this using your mouse. Just click on this and double click on this. You can see that using this keys they are joined. Okay.
Once they are made, can we change them? Can we change the
exactly. Any number of times you can change. Because see, this is editable for you, right?
Okay.
So once it is editable, that means you can change it.
No, why I ask this because is there a chance that when we are creating it, we can impose a restriction that it is only read only or anything like that?
No. On RPD whole objects you can do that, but on a single join and all you need not to do it. Okay. So close it. So now you have.
More than one.
Yeah, go ahead.
It has to be only one column attached, or it can be more than one column?
It can be more than one. Okay, now suppose for the same thing. So, okay, you meant to say whether it is just like this, only one column. You have more than one column. That is what your question is. Yeah, you see, this is in my case one column is doing my job. Suppose if I want two columns also, I can do like this. Now what you can do from customer, if I take city, from fact take something else. I don't have any varchar column here, that is the problem. Okay, from customer take rep number. You can select like this. Like this also you can do. And if you don't want, you can delete it also. Anything you can do, that's up to you. Okay? Okay, fine. Next. So you can see your star schema is being created. And physical layer will allow you snowflakes also. As of now, just look how your star schema is. So your fact table is there, and on top of it, all the dimensions have been joined. Right? So your fact in middle and your corresponding dimensions on the edges. Okay, which are joined. Fine. Next. So you can see your joins in multiple ways. Okay. Now observe the properties for your tables. For D1 calendar 2, when you click on keys, a particular key is being created for your alias. Okay. Sorry, for your alias. Because you are joining this with your fact table using primary key foreign key relationship. So this is the primary key. When you click on foreign keys for a dimension table, nothing should be there because it is not joined to any other table. Okay. Similarly, click for your fact. It does not have any keys, but it has 3 foreign keys because it is getting data from 3 different dimension tables. So it will be having 3 foreign keys. Okay. So like this. Next. So you have something called join manager also. So you can even explore the properties even there. So you have something called manage joins. So you have 3 joins now in all. So each join you can see. So from table D1 calendar to table fact D1 RSS2, you have a join expression. So if you don't want to edit from there, come here to manage joins. So where is manage joins present? Under tools, sorry, under manage, you have something called joins. Click on this. So if you want to edit join between fact D1 RSS2 and calendar to table, just double click and you have your join criteria. You can change it accordingly. Okay. So cancel this, close this, and save the RPD. Don't check any consistency. Just leave it like this. Okay. So today I'll wind up here because business model and mapping layer I'll start it on Monday because this may take some more time. 20 minutes is not enough for me. So we will do it slowly on Monday. No need to hurry. Is that fine? Okay.
Yeah.
Okay.